What's going on, guys? Chris here. So I am doing this video to show you guys the why isn't this lifting up? To show you guys how I finished up in the shop with all the stuff that I did with the lead screw, the electronic lead screw project, and the Precision Matthews mill upgrades and modifications, and moving my tapping arm back here, all the stuff I've been doing in my shop. So I got this bench on sale. I think I might have mentioned it already. I got another one from Amazon. It was junk. I sent it back. But I organized all my thread taps. So I actually got another like small 3-drawer that's meant for drill bits. I have my drill bits in that. I'll show you in a minute, but I'm going to put all the drill bits in one, and then I'm going to I made more of these for drill bits, and I'm going to make this get bigger because these are like go no go. These are thread gauges they're from go no go. There's just like a go no go, but for threads. And I have these in all different sizes, standard and metric, and then these are also different, just quick thread gauges just to check what size the threads are. And this is to actually check that you made the threads properly. And then these are all manual threading things, and those are all the actual taps. And then these are NPT taps for pipe thread. And then all my bolts are now in one cabinet. All my number 8 hardware, all my miscellaneous nuts and washers. And then these are reversing tools and my flange nuts and bolts. And then these are all socket head and button head, and they're all the way up to M12 or maybe even bigger. And then this is all this is extra stuff for the mill on the bottom drawer, extra parts for the mill, like the stuff to secure things down to the table and my rotating vise, and another smaller 3-inch vise, and my broach kit, and then all my gauges. These are all the square gauges, and then all my pin gauges. I have all the way from 61 thousandths to 500 thousandths, every pin gauge in between there. So I got a lot of precision measuring stuff. I got more than that too. I'll show you. And then I put one of my 2 big vices over here, along with the one that I had over there, and a power supply, because I'll need that in here. And this is my thread tapping arm, which this thing has been great for 800 or 900 bucks on Amazon. It's been amazing. This thing taps threads like perfectly. And I found this, and rather than having to write a whole CAD file to chamfer a piece of whatever work you're doing, they have these little pneumatic chamfering tools, and I got this for like 80 bucks. And for a pneumatic tool, I mean, that's not a bad price for a pneumatic tool. But my air's off over here. Come on. So yeah, you have your little guide bearing right here, and then it goes right around the corner, and it actually chamfers it pretty well if you take your time and do it nice and slow. And then I bought a kit of 0 to 4-inch Mitutoyo micrometers, which were very expensive. These were like $600 for the 4 micrometers. This is 0 to 1, and then 1 to 2, and then the 2 to 3 and 3 to 4 are in the other tool bench. But these are notoriously accurate gauges. And then there's a few few abrasive stones, and then those are universal spanner wrench. But as far as tools for this is the other thing I think I mentioned to you guys before. But this is a perfect center finder. This is really better than most of the other things. I mean, I have like a regular edge finder that's also a center. Where the hell is it? It's got one part on each side. It should be here somewhere. Where did I put it? And then these cable chains are here because I was going to do one on my x-axis on the CNC, which this is going to be a final video for all the things that I've been doing in the machine shop to show you guys where I landed on stuff in the end. I mean, I'm basically done with all of it now. The last bit of modifications I wanted to do on the CNC is done. The lathe, I do need to do a little more tuning, but it is making threads accurately. The mill is done. The only well, it's done, but I did a one-shot oiling system, and I got an electric pump for it, and the electric pump, the pump in it went. So I ordered a new one. I'm gonna return this one. I only had it for like a week when it blew. So I'm waiting for the other one to come in on Monday, tomorrow, and then I'll pour the oil out into the new one and put that in. But I got a manifold. I actually got an extra manifold. It's back here. No, I think I have it up in my other small shop up front. But the manifold has it has like a dial behind each output, and this one here on the mill has 12 outputs, and on the back of each output there's a screw, and it's a valve, so you can control how much flow each one gets. So if you have, like right here, these are very close on the mill. These, the manifold is right here, right back there, and that pump feeds the manifold, and the manifold feeds everything. So right here is very close. These in the front are very close, and they're not going up either. The ones that go around this side are a little further, but they're still not going up. So they get a little bit further open, but not as much as these, but not as closed as these, not as open as the ones that are up on the Z-axis. The Z-axis gets open the most because it's got to go all the way up. So, I mean, just use common sense. But as far as this, you put this right in the spindle, right, and put it in a collet, and this will go right around the work. You hold this, and then as it turns, this gauge will move, and you find the center really accurately. It comes with directions. You read them, and it's not really rocket science. If you know machining, it'll come naturally to you. And then, like I was saying about the drill bits, I put them all in here. And I ended up getting quite a few drill bits. And then you see all the brand new sets up on top. This is a Chicago Latrobe set right there. That was like $500, just $600 just for this set. I spent a lot of money in here just getting everything I wanted squared away the way I wanted to. But it's been great because now I know where all my drill bits are. They're all labeled by size, which I'm going to do in that 5-drawer thing that I got that's 4 drill bits. It has already a big thing across it that has spots to put the labels for what is in each part. And I have too many drill bits. They're not separated enough. I had to do too many in each place. So using those, I 3D printed those sectional things. I'm going to use those with the other taps and make more space for them. That will give me more organization for the taps and more organization for the drill bits. And then this is just miscellaneous tools, and then like a thread tap holder. And these are milling bits and surfacing bits, and then these are boring bars, and these are obviously hole saws, metal hole saws, and a couple of chamfering tools, and some saws for this. And this is a keyway, not a keyway. This is a gear saw. You cut out the gear holes, the gear notches, and then I have all different sizes of them. This came as a kit to make gears, which is pretty awesome. It makes them pretty darn well. And then I got some metal saw blades. That's a cutoff saw. So, and then I got a fly cutter for this, and I already had the surfacing bit, but I didn't have it on an R8 arbor, so I got the R8 arbor. And then I got a really good precision drill chuck. This drill chuck was like $300 just for this drill chuck with the arbor. I mean, it's a fixed arbor, so it's an R8 permanently. I have others for my lathe. So anyways, moving on. So that's what else I did to the mill. And then I don't know if you guys saw, I had a couple of the scales get messed up, during the process of putting the DRO on. But now I have the DRO goes off of the switch to the mill. So what I did is I used a 110 volt power supply coming off of one of the two legs of the 220 in the mill, and then I used the neutral from the outlet right above it. So I have this, it turns on with this, and then the other switch that I put there is for this, for the up and down, which I just have to turn the speed up. And I actually gave this 48 volts, and then I put a buck converter voltage reducer in the box also that reduces it to 24 for this controller. But the 48 volts is going to the stepper motor and to this DC motor, which makes my Z-axis and X-axis move a lot quicker. So if you saw it before, it didn't move nearly that quick. And I put the handle back on, as you can probably see. So yeah, it moves very quickly now. And the X-axis can too, I just have it going slow. But it moves with some authority. And it moves with that authority even through a cut. It just blows right through it. And then I found this magnet thing. This is for cleaning up all your steel chips. And then you pull this out and they fall off. But for the lathe and for this is fantastic, especially like the really fine ones they get in between here. I've seen a lot of people, they cut pieces of metal to fit around their vise. And that's a good idea too. I mean, you're gonna have to move them all the time. I would rather just use this and clean it up, and then I vacuum it out from time to time with the other machine. But all three of my scales are working. If you see the DRO, yeah, you can see they're all working. And then the Y-axis I didn't automate. It's short, it doesn't need it. I don't feel like that's something it needs. I can do that manually, no problem. But the X-axis is very long, and the Z-axis is a pain in the neck. And it's kind of tall, which is one of the big benefits, actually, of this machine versus the CNC. The CNC obviously has a tremendous amount of benefits, but that's not one of them, the Z height. But that's my next modification on the CNC. The CNC modifications were all successful. The only modification, I already have a CAD file for the Z-axis gantry risers. So there are two blocks that are going to go here and here underneath the gantry and give me 2 inches more height. And that's something I'm definitely going to be doing. I'm gonna source the material. I'm probably going to use either cast iron or some kind of steel. I have aluminum blocks big enough to do it. I have in my stock drawer over here. Yeah, you're not going to be able to see down here. This bench over here, this drawer is all full of stock, and it was a lot less full than this since when I was in it last time, when I was working back here and videotaping with you guys. But I've since gotten more stuff in here, but like these big aluminum blocks, I'm not going to do it out of aluminum, but that's definitely big enough to. It's more than big enough to do it. This is 2 by 4 by 6. So the 2 inches is what I need. I would just need to machine it to shape, and then machine the cut it and then machine the sides. But that's not happening. I'm not going to do that. I'm not using aluminum. It's just not sturdy enough, strong enough. Not on a cast iron frame and cement. I'm not going to weaken it with that. And then this is just all my extra pulleys and belts from all these projects, and I'm sure I'll use them on something. And I've got tons of extra motors, and then this is just extra parts for the lathe. This is an extension for the tailstock, and another live center, and then my main live center's in there. And this is an ER20 collet that is in a small chuck that goes in the tailstock and also goes in my thread tap. That's what that's for. I machined that to go into my thread tap, but it still goes in the tailstock. And then I can use this for taps. And then I have the other part that I can take this chuck off and put the die holder in there. So I can do male threads and female threads. And then this is my keyless chuck for the lathe. and my regular standard drill chuck for the lathe. And then my other two micrometers that came in that kit are in my measuring stuff in this drawer. There's the other two bigger Mitutoyos. This is the 3 to 4, and then the 2 to 3 and 3 to 4. And then this is actually an AccuSize digital, and then a 0 to 6 and 6 to 12 or 0 to 12 dial indicator calipers. So, and then my tachometer that you guys have seen me using, trying to get the RPMs right on this. And then these are all lathe tools, and these are all milling tools for the CNC, and well, for whichever mill I need them for. But these are all the ones in this drawer, and then that's basically it. And then so let's get back to the CNC machine first. The CNC machine. So I ended up waterproofing these servo motor drivers that are part of the servo right on them. I don't know if you can tell how I did it. I used 6 mil plastic. That's what I did first. You can't see it now, but there's 6 mil plastic around it for my lead stuff. I had some heavy plastic. I just cut the plastic and then I wrapped it around the perimeter of the driver. After I did one layer, this is electrician's tape for exterior, and that stuff sticks to itself so well you can actually submerge it, and like right after it sticks to each other, within a minute or two it can be underwater and it won't leak. And it's expensive, but it's very well worth it when you for the applications it's for. You need it. It's worth it. And then I increased the size of the cable chain so that I don't have any issues with that popping the things out like it was before. And the cooling system you saw already, which is working great. I'm going to show you that to you in a minute. And the end stops, the end stop switches, I changed all those, and I got some small ones, the same size as the ones that they have in it originally, just waterproof. I guess they have waterproof ones now, but I got this machine when they were first selling them, like now I don't know how long after, but they said they've been selling them for 2.5 years, and I've had mine almost that long. I think it has been that long. So it must have been in the very beginning. But these are the old ones that I got, not the old original. These are the old ones that I got. You see how it has that little grommet over the button in there. So that little rubber over the button, and obviously it's sealed. But I had a couple of these break. So when this had hit it too hard because I was doing whatever else I was doing, these broke very easily. And I decided to get some bigger limit switches. I'll show them to you a little closer. And these ones are fully waterproof, but these were like $13 per switch, which is expensive for a limit switch. If you can see it now, they're a lot bigger, a lot beefier. They have the rollers on them like this, and I do like that because the first time I tried them with the rollers, I zeroed it, I homed it, and then I moved it and put the new limit switches on. They were the same size and just with rollers before I even got the waterproof ones, regular rollers. And when I homed it again, I had more space. It was more precise with the limit switch, the other limit switches. So I've been sticking with the rollers ever since. And I also got the upgraded version 2 of the probe, the touch probe. And I 3D printed this. That's probably because I have that on there. I can't really grab it very well. I 3D printed this little mounting thing for the oh, you can't see. This little mounting thing right here. I put the touch probe in, and it sits right inside the machine. I had one that I sat outside, but this way I don't have to unplug it all the time. So this is upgraded. You see how it has 6 screws in here now because they modified it, and there's a new PCB that you take the old one out and you put the new one in. It's relatively easy. And honestly, if you already had it, they give you this one for $20. So they do you pretty right on that. So I got that, and then I upgraded the cooling system as I've shown you, and I'm going to show you again. And so the drivers. So I wrapped that tape first around where the dip switches are. And then over that, I sealed I'll show you exactly what I used. I sealed the perimeter of on top of that tape with the inside the plastic with this. This is exterior roofing, you know, like it's like a, what's the common one that I used? I can't think of the name of it, but this stuff is made by DAP. You can get it at Home Depot. It's usually in a caulk tube. I just happen to have one of these smaller tubes, and this was good for this. So I put a bead of this on the 6mm plastic, wrapped it around the perimeter of the driver on top of that tape, and then zip tied it overnight. And then the next day, the seam, I sealed the seam, and then I sealed it all the way around, and I ended up going over the whole thing with that tape. So that's that rubber tape that sticks to itself. So I mean, I could literally spray those with a power washer and they won't get wet. And so I did that on all three, and the same thing with the limit switches. I left the smaller limit switch on the Z-axis because the Z-axis is not really very hard on it because it moves pretty slow, and it's not going very far. I mean, they all do when they're homing, but I guess I probably should have done the Z too. But also, these were a lot easier. I had to drill and tap new holes because those are so much bigger. The holes are in much different spots, and I used M3 instead of M2.5 screws. I used low-profile screws. They have bigger heads, and they're lower profile, and they also have a larger head, so it has more surface to secure it down. But I drilled and tapped those with a bottoming M3 tap, and it came out perfect. It worked out great. I just had to get them in the exact right spot, so I had to, get it all the way where it was going to home, and I'm like up in the machine while I'm doing that. And then also I put a couple fans up on the top. I don't know if you could see those. I put a couple of fans, so when it's wet, I can turn those on and let it dry a lot quicker. Let me briefly show you this going with the coolant before I move on to the next thing. Move on to the finished lathe with the lead screw thing that I did. I'll turn on the 220 here. I'll turn the spindle on. Oh, and then for the pendant, I made a little housing for the pendant, a little 3D printed mount. They sell these on Limar, but you can just make it on a 3D printer. Or if you guys want one, email me or comment me, and I'll make you one for probably half the price. Pay for the shipping. Okay, let's see. And I did get a new touchscreen. If you guys saw in the other video that my touchscreen wasn't working, and I actually got it working with the touchscreen actually working, because in one of the other videos the touchscreen itself wasn't working. So I got it working by using both of the two USBs. Oh, I did proceed without homing. Why did I do that? Home machine. Okay, so there it is homing. You see how silent it is? All you hear is the ball screws. That part is so great. It's just so quiet. I'm not sure why this one thing is not getting a lot of flow. It's right next to that one. It should be getting the same as everything else. That's kind of weird. Let me see if I can't figure out why that's doing that. See if I can stick something in there. What do I have to stick in there? Oh, maybe like an automotive pin might fit. Let's see. Do I have a straight one? They're all curved. I'm going to try to find something to stick through there, because I don't know why that one jet was getting just as much flow as the others. Oh, here we go. I got one of my automotive painting brushes to clean out the tips. This should fit in there and clear it out at the same time, hopefully. Come on. That's too big. Son of a... Son of a gun. Oh, you know what? Here's a paper clip. That'll work just fine. There we go. Yeah, it was getting just as much flow as the others. I don't know what that was about. Now let's put it on 5,000. So yeah, you can see all the jets are hitting right on the bit. So it's perfect. And I cleaned out all my drains. I power washed in here. I'm actually going to re-epoxy it. I'm going to. There's some spots that chipped up, and there's a couple of spots where things got messed up. So I'm going to let this thoroughly dry. Next time I don't use it, which I don't know if I have to use it anytime soon. I probably will, just because I just did all this work to it. But I do really want to get that Z-axis done. So I'm going to look for the material for that. I need two 4.5 inch by 4 inch by 2.5 inch, because sometimes when you order stock, it's half an inch or more off. It's up to half an inch off. It's supposed to be less than half an inch, but it can be up to half an inch. So I want to order it and make sure that I have at least I don't want to be under the 2 inches. I want to be exactly precisely 2 inches when I'm done machining the parts. And I'll machine them myself. I'll just order the stock. I mean, it is something I would have made, but by the time I do that, even just the material, that size of the kind of material I want to use, the cheapest one is going to be the cast iron, and it's honestly probably going to be the best one for it, because it absorbs vibration better than any other material. So some of the parts in here are aluminum, but the gantry is steel, and the mounts are cast iron. So one of those two materials I think would be fine, but I just don't want to put aluminum in the middle of them. But some, like the motor and ball screw mounts, are aluminum. Probably this part on the bottom. I know those are, because I just had to drill and tap them. I don't know for sure about the bottom part. That probably is. Maybe this part is steel underneath. I'm not 100% sure. I didn't pay much attention when I was putting it together. I was too focused on coplanarity and everything being level and all that. But I guess I probably won't find out. I'm just going to do it in cast iron or steel, because I want to do it in that. Sorry about that. I'm just getting the water out of there. All right, or the coolant rather. And for the lead screw. So the lead screw project is done. I just need to do some tuning on this servo motor, but that's, I had to do that on all of them. And the DRO is all set. I got that in and done. There's my DRO. You can see that's working. And this has a lot more features in it than the old one did. I keep this micrometer because I usually have this on the actual chuck, because I like to be able to see that the chuck is moving evenly. So that's probably where I'm going to put it back to. I had this positioned where it was resting on the chuck, and I could see that the chuck was, I was not getting too much vibration off of the chuck while it was moving. So let's try to position it back there. This is where I usually have it, somewhere right about there. And this is a good AccuSize. This is a 1/2 gauge. And then this is actually an AccuSize chuck as well. This is a new chuck that I got, a 6-inch. I have an 8-inch and an 8-inch, a 5-inch, and a 7-inch. They're all, only one is a 4-jaw. Oh no, I'm sorry, that's another 6-inch. The 6-inch is, I have a 6-inch 4-jaw, and then a 6-inch scroll, and then a 3-jaw self-centering scroll, and the 5 and 8-jaw are also self-centering 3-jaw. Scroll chucks. So I'll show you this going and see where that's usually within 0 to 2.5, sometimes up to 5 from the vibration, but 5 on this gauge is 5 tenths, 5 half-tenths of a thousandth. So it's about 0.5 of a thousandth, because it's tenths. That would be 2.5 to 5 tenths of a thousandth of an inch. So I mean, most of that is just vibration, honestly. That's even when I go up faster, it's mostly vibration making it move, but it'll go a little under 0, but it's still under 5. It's still like 4 or 5. So it's pretty darn smooth. And it's set up the way in here, the same way you guys saw it last. And that's pretty much it. I've shown you, some threads that I had done on here and measured them, and the thread pitch was correct. I just have to do some this thing has plowed through some serious cuts with aluminum. I haven't gone too deep in steel. I did do a piece of high-speed steel, which was a very challenging cut, but I can't go very deep. But you can't cut high-speed steel very deep really, I don't know how you could cut it very deep. It's very difficult to cut. But this didn't hesitate at all with it. I mean, even though it's very light cuts, because you can't get deep with it, you just can't take big chunks out of high-speed steel. It's brutal to cut. But this is the high-speed steel piece that this was like a foot long. So I don't know if you can see the the markings in it. It's HSS 20 by 150. It was 150 millimeters long. So the rest of it I used for, I forgot what it was for, honestly. And then there's some high carbon steel over here. Yeah, I bought some stock. I need to get some more stuff just to have it, because when projects come up, I don't usually like to have to order stuff and wait for it in order to make something. When it's in my head, I want to make it right then. But like the CNC machine, that's a project thing that I'm not going to keep that size in stock. But typical standard stuff that I use for a bunch of different things, I will keep in stock, which is why I'm going to order it to keep in stock. But anyways, all these projects turned out to be successful, so I'm grateful for that. And I'm very happy that it's all done. The only other thing remaining being the Z-axis risers, so I can have a little more height in the CNC machine. But I definitely have enough width and enough depth, so the X and Y axis, I'm happy with the size. I'm eager to get the extra Z height, because that's the only thing that's lacking in this. Even with the very low profile vices, and they are low profile, they're only a couple inches high, but there's a lot of projects that are just not gonna be accommodated by this. For instance, I resurfaced my brake rotor recently, and again, another one, and I did it on the Precision Matthews, because I can't it's for my truck, and if it was my Brembo brakes on my Challenger, I don't think I would do it. I'd probably just get a new rotor, but I don't know, I might try it. Anyways, I wanted to do it in here, but I couldn't do it in here because it wouldn't get high enough. The brake rotor is so big, it's so deep on my heavy duty trucks. They're both 2500 heavy duty diesel trucks. So the brake rotors are big. They're very deep, and they're 14 inches wide, and they're even the rotor itself, the contact surface is very thick. So it's vented in the middle, and then there's like the two surfaces. So it's pretty high up. It's like I don't know, 7 inches high. So this doesn't go 7 inches high. It's going to. It'll go almost 8 inches high when I do the 2 inch. If I don't decide to do 2.5, I might actually do 2.5 inches. I do have the ER20 collet extension that I just showed you that I actually use for the. I bought that from Langmeyer with that last order with the upgrade for the touch probe and all that, and that's what it's for, having the bit closer to the work without having the spindle so much lower. But I actually bought it thinking of using it for my lathe, and that's what I've been doing. And I'll just alternate and switch it back and forth if I decide to go any higher than that, or maybe even at that height if I'm doing something that's really low and it needs it. But the height is definitely something you can always compensate going down, because you can put something underneath it. I mean, and the Z height goes lower than it'll hit the bottom. I mean, I surfaced the bottom with it. So I wish I had a surfacing bit at that time. I did that all with a 1/2-inch bit. But I mean, they do give you the CAD file for that. So it did it. You know, it came with it and it did it on its own. But anyways, so yeah, that's it. I'm wrapping up the video of all the upgrades in the shop. I got a lot of stuff done, and I went further than I expected to on all of it, like usual. So I guess I didn't disappoint there. But I'm exhausted. I did a lot of stuff in here, and I've had a lot of other stuff going on the whole time, like usual. So it's been a little bit of a challenge. Recently, my mother was just in the hospital, and you know, I've been dealing with that and going back and forth, bringing her dinner there and trying to be there for her, and you know, I'm still managing to get to this stuff. It's not easy, but I'm managing to get to it. But I'm gonna give it a rest for a while. I'm gonna just shut this off real quick. I'm gonna give it a rest for a little while. I'm gonna order the stock for this. I already do have, you know what, I'll show you the CAD files real quick, because I have if anybody wants those, I'm happy to share them with you. So just comment if you have an MR1 and you'd like to consider raising the gantry for some more Z height. I already have the CAD file. I'll show it to you here momentarily. I already have the CAD file for raising the gantry, and I'm happy to share that with you if you guys are considering or going to consider doing it as well. I'd be happy to give it to you. I've double checked it. All the measurements are good. I hear myself talking, so the last video I started processing for you guys is done. So you're gonna hear me in stereo here. Oh, and triple.
This is more than that, just the board.
There we go, triple. Oh yeah.
The screen of it anyway.
I don't like to keep hearing. I don't like to hear myself that much. Okay, there we go. All right. So that's done. That's another video that's for you guys. All right, I'll put that up after we're done here. And this is Langmeyer's site. I've been considering a Crossfire, so that's what I was looking at there. But this is, yeah, see the version 2 probe is $150, but if you already have the probe and you get the upgrade kit, let's see where that is. Featured products, where's the, oh, let's see, Crossfire add-ons, MR1 add-ons. Okay, so they have that's the extension for the ER20 collet. That was $40. That wasn't bad, I didn't think. I mean, it's, you know, it is what it is. It's an arbor and a collet, and it only comes with one size collet, but it's $40 is $40. The lift kit for $150 is excessive. I mean, it's a few pieces of metal, and it just so that you can hook something to it to pick it up, which I think is too much. I think that's too much. I mean, I could just make that, but they are selling those 6x4 by 2-inch aluminum blocks for $25. That's a good price for that size piece of stock. It really is. So that I was pleased with. The wash down hose kit. Everybody's been doing this anyway. I mean, it's a sprayer, a hose sprayer, and a piece of rubber hose, and it's $60, $55. That's a little much. And then the aluminum jaws, they have soft, quote unquote, soft jaws that are aluminum. And I bought 2 sets, one for each vise, and they're not from my vise. My vise is, I bought this so long ago, the vise changed. And that pisses me off. And now I still have them, and they want me to pay to ship them back to them. Like, dude, you sent me parts that don't fit. I don't want to give them a hard time. They've been good to me, and they are really awesome. They're really awesome. They've been great with support and all that. But $100 for a driver, and their high power driver is the same one that was on the Z-axis. And I got to tell you, it's a piece of shit. It's like a cheap, no name if you look for the shittiest drivers on Amazon, it's a bigger driver than they have on the X and Y axis for sure. But you're talking $300 just for drivers on X and Y. You can get for $40 or even $30. You can get the same big drivers that I used and I'm using currently on the Z axis. But you can get the bigger digital drivers that are going to be more quiet, more torque, can take more power than even this for less than a third of the price. They're out of line on that one. That's more than triple the price of what you can get it for online. And you know, I mean, the tramming tool, that's a good price, $15 for a tramming tool, because that STI one I got, Stupid Simple Tools. SST, Stupid Simple Tools. I got their tramming tool with the 2 gauges, and that was $100. So, and then the tool setter riser, I think I'm going to just print that. So I'll just design it and print it. And the fusion coolant for flood coolant for $50, that's about what you pay anywhere, so that's fair. The pendant is very fair for $20, but that thing is junk. It fell apart on me. I got one from Amazon, but I made sure I got a good one. It was like $40, but it was worth it because that thing just fell apart. The buttons like literally fall out. And then the 120 volt spindle transformer, if you don't have 220 volts, you have to get that. That's not optional. So I mean, for something like that, the price is totally reasonable. Most of their prices are very reasonable. I can't really say that they price. I mean, there's a couple things that I think are a little too high, but there's most of their stuff is really fairly priced. Even like the half-tenth indicator with the magnetic base for $40. That's not, for that gauge, that's not a bad price at all. I mean, they're actually pretty darn fair. And I mean, look at the price of the machine with what it can do. I mean, you can't even find that anywhere else. I've looked, you can't find it anywhere else. So I was considering the Crossfire Pro, which is this right here, and I will make some videos with it if I do end up getting one, but it's like $3 grand for I don't need the water table. I guess it comes with a water table. I don't know if I need. They're acting like they give you Fusion with it. They're not paying for a Fusion subscription. I think I would just get the regular one because the Pro, I don't need the. Let me see. Does it have is it an automated height? No, it's not. Oh, is it? No, I think it is. It does have automated height, I believe. Yeah, automatic. No. Oh, you have to pay $400 more for the automatic height. So I could probably do that on the regular plasma, you know, the regular Crossfire instead of the Pro. This is $1,500 for the plasma table, fire controls, and so it's just a plasma table basically. And then the XL expansion kit makes it bigger. That's $150. Z-axis upgrade kit includes Z-axis, THC, ICS. So that's your height automatic height adjustment for $550. So then you're at $21.95. I don't need the water table. I have a workshop. Laptop stand. Laptop stand might be a good idea for $85. Yeah, I'd probably have to do that. And how do you not? They have a limit switch kit. How do you run it without a limit switch kit? Don't you need limit switches on it? I mean, I could run limit switches, but I don't know if that has something that's to interface them with the platform that they have, or if I who knows. But I have the plasma cutter already, so I have it's a 65 amp, so it's a serious plasma cutter. I don't really need any other hardware other than this right here. So even if I did add the limit switch kit, it's like $2,400 out the door. I mean, well, before tax and shipping, and it's $150 shipping. So it's probably almost $3 grand with all the stuff that I mentioned. So it's definitely not cheap. I mean, it looks cheap when you see $1,500, but it's, you know, it's double that by the time you make it bigger and make the auto height adjustment. And I mean, I could live without the auto height adjustment, but if I'm gonna do it, I'd rather just do it right. But yeah, anyways, I'm thinking about this, I'm considering it, but let me show you the Z height gantry risers. Here goes Fusion. Luckily this computer is extraordinarily fast. Let's see what the customers have to say. Yeah, I'm going to do that. The customer reviews honestly give you a very good insight into things before you buy them. The plasma cutter, it just seems like such a good idea, because cutting with the plasma cutter is almost impossible to cut straight. All right, no, I need to, let's just close that. I'll open it. It's not one of those. Open. MR1 gantry riser. Okay, so this is the gantry riser. Let me bring you guys down a little lower so you can see better. So that is the gantry riser. And let me grab this space mouse. So this is that part with the beveled sides that goes underneath the gantry. And the holes are all in the right spot, same spot as they are now. And the, why is my, oh, am I holding it wrong? My turning is not turning. Where's my, I hate this space mouse. It seems like every so often I have to reset the directions and whatnot for it. I don't know why that is. And then it usually is set up, you can set it up for Fusion. Advanced settings. Oh, it's not doing it for Fusion right now. Why is turning not working? There we go, Autodesk Fusion, here we go. It did change it when I started moving in Fusion. Okay, navigation, pan, zoom, rotation, dominant. Zoom direction is, I like forward and backward. Rotation center, auto, and speed, okay. Well, let's try to reverse that one and see if that helps. No, that's not. I don't know why it's not moving that way. Let me turn up the speed on that and see if that does it and take the reverse back off. It's just turning it like, it's like, that's supposed to be this. It's supposed to be that. I'm just turning it. Come on, let's turn it. No, not that way. You're turning it the wrong way. That's supposed to be, I don't know. Anyways, this is the other side. And you can see all even the sides are beveled. If you guys can see that, then that top part is beveled a little, well, quite a bit deeper, but all the sides are beveled smooth. But this will fit right to the underside of that gantry, and it'll, you know, mesh right in with the front of it, because the you know, the flat part is going to go on that bottom slider, and then that's going to go right underneath the gantry the way that it fits, and that's for those bevels are for the welded piece on the front, the gusset on the front of that gantry. But I'm happy to share this with anybody who wants it. So just reach out to me if that's you. Oh, there we go. Just reach out to me if you guys want a copy of this CAD file. I'm happy to email it to you. You know, I'd like to see you guys have, you know, make progress on modifying your stuff if you want to do it too. So just let me know if I can help, and I'll send it to you. All right, but yeah, that's the next project, and I will make a video doing that when I'm machining it, and when I when I put it in, and how much actual height I get from it. So if you're interested, then you can, you know, subscribe and look out for that video, because that'll be coming up fairly soon. I'm going to start looking for the material after I upload this video. All right, so it's Sunday. I'm going to make good use of it. All right, I appreciate you guys as always, and I hope you enjoyed the whole machine shop upgrade little bit of videos here. And I got to do some more stuff with the laser engraver, and I have a fiber laser over here that I got, and I haven't really done a whole lot with it. I mean, I've laser engraved some stuff, but not I haven't done a lot. I did an unboxing with it with you guys. I didn't really do any other videos other than that, but I will. And that's it. Other than that, I've been upgrading my printers that I built, my 3D printers. I just printed this with one of the ones that I built, which was pretty impressive, that there's no stringing, and it came out really good. But anyways, I will see you guys on the next one. I hope you enjoyed, and like I said, feel free to leave me any comments, and if you're doing something that I can help with, I'm happy to do that. All right? Thank you. Later. Hey guys, what's going on? It's Chris. So I just wanted to let you guys know, so I just did a whole bunch of videos on the MR1 and all the modifications that I did. The V2 touch probe didn't work out for me. I had ordered the upgrade kit, and then I ordered a whole new one. Langmeyer's been great. They're going to give me a refund on everything, but it didn't work out for me. I know I've seen other people online that it has worked out for, so I mean, maybe I just had a bad experience. I don't want to say that, you know, they're all bad. I don't know if they are. But they said they were working on them and stuff, and they gave me no hard time about it. So more importantly, I did a bunch of stuff. You'll see if you've seen the video already. I did upgraded steppers with upgraded stepper drivers, digital stepper drivers, high power and high power steppers. Then I decided to change to servos, like the one I used on the electronic lead screw. So I got all easy servos except the Z-axis, because it was whining. It needed a break. So I just used a closed loop stepper. Now I decided, because I'm going to add a lot of weight to the gantry, because I mentioned in those videos, I'm going to raise the gantry up I decided on 2.5 inches. This is my CAD drawing of it. This is in the machining section, but this is what I'm going to be doing. This is, as you can see, this is the gantry, the riser. It's gonna go between the y-axis and lifting up the gantry by 2.5 inches, 2.25 inches. So that's the CAD file for it. I don't know if you guys can see it very well, but it's on the screen. And then here, what just came today is the material. Gray cast iron, got it from McMaster Car. If you can see that huge block, that thing weighs 60 pounds. 60, yes, 60 pounds. Yeah, they had 3 1/8, and then it went right to 6 7/8. So obviously I had to get 6 7/8 because one dimension is almost 5 inches. This is very, very heavy. So it's about 3 inches by 5 7/8, which is really like 6. Now that I measure it, by a foot. So it cost me, a good amount of money, but I got a price from Online Metals, and they were more expensive for 2 separate blocks that were much smaller and not machined or anything, just cut. And they were about $100 cheaper, more expensive than this. So I got a lot of extra material that I can use for something else, and I got it for $100 less. And then I ended up getting a couple of handles for my Precision Matthews mill that fold in, so that when the power feed's going, it's not swinging that handle around, which is a good thing. But so I ordered Clearpath stepper motors for the extra weight, and because I really wanted to try the Clearpaths. This is a video I'm putting together for you guys right now, and then I was reviewing before I started putting them together. But here's the Clearpaths, and these are the ones. Which ones did I order? Hold on, let me log in and I'll show you. Here we go. There's my order right there. So I ordered 3 of the, it cost me $1,000 for 3 servos. This is what I ordered. CPM SDSK 2331 S-RLS. And I ordered, their power supply is only 350 watts. I ordered a 1500 watt 72 volt 1500 watt power supply from an independent third party. So I'm going to be using that power supply, and I'm going to make my own wires. So I just ordered the 3 motors. So that's literally just for 3 motors, cost me over $1,000. But they're really good motors. They have a seal on the front so that they're watertight. And really, these motors have such a good reputation. I ordered the same size for all 3. I figured having 2 bigger ones on the Y would be a good thing, especially since they're the ones moving the gantry weight. The X is just moving the tool head. So I think they need to be bigger now. But with the way that Clearpath has it set up, they're not nearly as big as a traditional stepper or easy servo. That's less powerful. These are tremendously more powerful. These are smaller, about the size of the smaller ones now in the 2 Y-axis, and they're way more powerful than the bigger one on the X-axis, like a tremendous amount more powerful. Their peak power is 600 and something. Here, let me pull up this spec sheet. Oh, right here. Okay, 620 ounce inch, 4.4 Newton meters is the peak torque. The RMS consistent torque is 124. So let me peak power 193 watt. Oh, if I'm giving it the full voltage, which I will be, it'll be 193 watt consistent. So if I go to Stepper Online, let's see. Stepper Online. And then we'll pull up the easy servos. Okay, so I have 2 of the 90s. So they're these 0.3 Newton meters, 42.49 ounce inches. And the 180, this is 0.6 Newton meters and 84.98 ounce inches of torque. So it's a tremendous improvement in power. Obviously on the Y-axis it's going to be a really tremendous amount. It's the difference between it, because it's the difference between 2 of the lower ones and that same amount for both of the Ys. So it's going to have a ton of power, and also their peak power, it can be sustained for a time, like, and it only drops with RPM, and I'm not going to need 1500 and 2000 RPM, so I could probably have that power all the way. I mean, it starts dropping at like 400 RPM, and then it drops really significantly at like 750 RPM. I don't think I'm going to get to either of those RPMs just doing 100 inches per minute. So frankly, I'll probably have a ton more power than I'll need. But that's a good thing, because that leaves room for upgrades. So I couldn't call this project done without it really being done. So I got the material, I got the CAD done, and I'm doing the cam right now. This is my second process. I'll show you the simulation. Hold on, I was in the process of making modifying this simulation, because I have to change a few things. Simulate, let me put it in a better view and play it. So that's going to be the center to remove some mass. And then that's the stock form. It is shaped underneath. That's my long roughing mill, and then I'm going to do another finishing pass with the long end mill, 1/2 inch. So that's that process, and then the facing process before I do that is right here. Now let me exit this one, and let's simulate this one. to simulate. So this is obviously, it's just like 3 passes. It's pretty basic. And so that's that. And then I got to do my drilling operation and blah, blah, blah. But yeah, so it's coming along. I'm going to cut this with the bandsaw, and then I'll machine it. I'll machine it to where I need it with the mill, with the manual mill. I'll get it smooth in all machine surfaces. And there's going to be stock left on the bottom because that's almost 3 inches. I'm going 2 1/4. And then I bought that extension for the ER20 collet, which will be perfect because if there's stuff that's really low to the table, that'll be able to reach it. But right now it can go low enough where it'll bury the tool in the table. So even with an inch, you'd still probably be able to hit the table with the tool, depending on the tool. So I think 2 1/4 is a good number, because things are almost always in the vise. So that's not something I'm worried about being an inch or an inch and change off of the table, because you never really need to be all the way down to the table. But I'm excited about getting this all done. I really am. I'm excited to try the new Clearpath motors, and I'm excited to get that gantry lifted up, because that's something I've wanted to do since I got it. So excuse me, I'll show you, I'll bring you back in the shop with me real quick, and show you what I've got going on back here so far. I believe you guys may have seen everything if you watched the other video that I had going on back here so far, but at least you'll get to see this machine upgraded with new stepper motors with higher power drives. The drives can go up to 8 amp, and the motors were 3.2 and up to 4 Newton meter of torque, and they were 4 and 6 amp. So there's still one that's 3.2 on the Z-axis. It's a longer one, and that's only, like I told you guys, it's a closed loop, but that's because the one that wasn't closed loop was more powerful, and I'm not even using the encoder, so I probably should have left that one, but hindsight's 20/20, because I'm still not changing the Z-axis. Honestly, with the Clearpath, I should have probably got another Clearpath and got the brake, but I've gone crazy on this machine, so at this point I'm ready to just make these my last modifications for a while and see how it does. But I'm sure it's going to do great, because it's doing great already with these, and with that amount more power. And I ordered new couplings, because I don't want to machine these out any further. I'm going to leave them at 8mm to 6mm in case I ever want to change back for any reason, which I doubt with the Clearpath, but we'll see. If I ever do want to, I want to have them. And that's about it. I did the cable chain. I did the coolant system that's fixed, so it's not flopping around all the time. And I mean, it's cutting like crazy. It's moving smooth as hell. I machined a couple of parts. I did some engraving, and it's working phenomenal. So, and then for the mill, these were expensive. These were like $40 per handle, just for the handle. But it's nice not to have that thing flopping around, whacking on stuff when I'm using the power feed. Like, I'll show you. You see the x-axis there, right? So if I leave the handle out, that's kind of, it's nice to be able to not have that handle swinging around like that. So, and then I did the one-shot oiling system with that timed automatic oiler, and it goes through a manifold with different valves on each fitting, so that the ones that are up higher you can open a little bit more, the closer ones you can close a little bit more. It worked out really good. And these servo motors, I mean, I already bought, and they're bought and paid for. I don't know what I'm going to do with them, because I have an extra small and an extra large one as it is. So that's going to be 3 small and 2 large ones that I don't have a project in mind for yet, but I'm sure I'll come up with one. But that's what I do, right? Come up with projects to do. But I'm I'm sure I'll be glad I have them when I need them. But yeah, that's what's going on. I just wanted to update you guys. I'll probably put this in the end of the video that I'm going to put up with all the stuff I had done so far, so you guys can see the enclosure, the electronics enclosure. I rerouted all the cables. I cleaned all that up because it was kind of a mess. Kind of maybe they were in a rush making a lot of these things, I'm sure. But you know, I'm a little anal, so I put cable raceways and organized everything. I put heat shrink labels on everything, and I, of course, went and spent like $1,000 on Knipex electrical tooling, like the ferrule crimpers that were $250. But honestly, they are really nice. They work really good. They're really awesome ferrule crimpers. If you guys are looking for some really high quality ferrule crimpers and really high quality wire strippers and really high quality tools like that, that's where to go. Knipex is definitely one of the top ones that I've seen. And I'm always willing to spend money on good tools. So this is the ferrule crimper, and you just go straight in the front with any size and it auto fits. So it makes a nice square connection, nice and tight every time. I got needle nose pliers, flush cutters, the small screwdrivers that are not that small. They're pretty big, but this is the perfect size for all the small flathead terminals on Phoenix connectors and on screw terminals. Perfect size for all that. So they make some great tools. And then this is just a standard insulated connector. And then I have a crimper on the way that's for like JST connectors and uninsulated. So I'll fill this whole thing with all my high-end electrical tools. But that's that. I mean, so I'm happy to be able to bring this to you guys. Hopefully it's helping somebody that wants to modify this CNC machine, because I know it's getting more and more popular, and I see more and more videos and more people are buying it and modifying it as well. I have seen somebody go further than me in some ways, like they did a new spindle. The spindle has a tool changer and all that. I like the servo as a spindle motor. Servos have a ton of torque, so it's not just about the speed. They have a ton of torque. So I think I would take the balance of torque and speed over the ridiculous speed without as much torque any day of the week, which is why I am. That's why I'm sticking with the servo. It's a huge AC servo, 220 volt AC servo for the spindle motor. So I'm sticking with that, and I'm happy to be sticking with that. If I do change my mind, I'll get a water-cooled 2.2 kilowatt. I've already looked at them and have a good idea which one I would get if I were to do that. But I haven't decided to do that, and I don't anticipate that I will. But if I ever do, that's the one I'll probably get. It was 2.2 kilowatt and 24,000 RPM and water-cooled. But anyways, I'm gonna stick with what I got on the main spindle motor for now. Just the X and Y axis are gonna have Clearpath servos and really powerful ones. So it should be a monster CNC machine when I'm done. And 2.25 more inches of Z-axis travel. So I'm very excited about that. But anyways, I just wanted to let you guys know that all that stuff is to come. So if you want to see all that done to this machine, stay tuned. And you can like and subscribe if you want. I don't really ask people to do that, because if you want to watch the videos, you can watch and you don't have to subscribe. I'm not going to try to push you, but if you want to, you can. I mean, I don't make money on this, but at least it gives me the feedback that, like, people enjoyed this. I'll do more stuff like that. So basically, that's what good it is to me, is that I know you guys enjoyed it, and then I do more things like that. So just let me know that way, so that I know, you guys enjoyed it. I'll do more of those videos. The more views and the more likes the video gets, the more videos like that I'll do. So I figure that makes sense. All right, so I appreciate you guys. Just a brief video today, just letting you guys know what the next steps are. Obviously, I've already got the material here, and I've already made the order for the Clearpath. Let's see when they're supposed to come in. Let's see. Does it have a tracking number? Well, it's probably in my email. And I have a ton of emails. Let's see. McMaster car. That's where I got the handles and the stock. That's gray cast iron, by the way, if I didn't mention that already. Maybe the next page. I get a lot of emails every day. Let's see. It's going to be under Technic. Could it be that far already? No, I delete a lot of them. Maybe I missed it. Let's see. These are all new. MasterCard receipt. Technic right here. New order. Okay, so here's the order. $1,040.62 for 3 motors. It doesn't have a tracking number yet, but I don't imagine it'll be today's Tuesday going into Wednesday. It's Tuesday evening. It's not really that late, 9 o'clock. So I don't imagine that the motors would be here any later than the beginning of next week. So when they get here, I'll be installing those promptly. I already ordered longer bolts to go through the Z-axis rays. I already ordered, and they're 12.9, very hard flange bolts, the type I like. And I'll retap the holes because I don't use standard anymore on anything, so I'll retap it probably M10, a little bigger than what they are now. So maybe even M12. No, I ordered M10. It'll be M10. I'll probably flip the gantry over, bring it over to my thread tapping machine and tap them myself. I have bottoming M10 taps. So I'll do that, and I'll put bigger bolts, put the bigger bolts that I ordered, the flange bolts, and then what else? The motors will go, even if I haven't gotten this machined yet, I'm going to put the motors in because those are going to be relatively easy. I just have to make the cables. And I may be able to use I did put heavier gauge wire for the power supplies to those 3 motors because I put 48 volts, which was 36 before. I think that wire can handle 72. It's 14 gauge wire, so I'm sure that's totally fine. That can handle 15 amps on 120 volts, so it's fine for that. So I can use the power wire, and then the signal wires are totally fine too. So I can just use the wires that are there. I'll just have to put them into the Molex Mini that is what Technics uses. So I already ordered a set of the Molex Mini connections and in all different sizes. So I'll be making those wires as soon as it comes in, or crimping those fittings as soon as it comes in. And I ordered the power supply, which will be here Thursday. So by the beginning of next week, I'll have everything to do the motors, and hopefully this weekend I'll get time to machine this stock into what I need it to be, and then get all this stuff done next week and put out another video for you guys with the third time changing the motors on this machine, which will be the final time. I really wanted to do the Clearpath in the first place, but they're really expensive motors, obviously, and I was hesitant because the other motors I got are like 90 and 120 20 bucks a piece. The one was 120 and the other two were 90 bucks. So it's, for those 3 motors, it's not even one of these. So it's literally triple the price, and then a bigger power supply that I didn't have. So it's substantial. But anyways, I feel like it's going to totally be worth it, especially with all that extra weight on the Z-axis. I mean, on the I'm sorry, on the Y gantry, Y and X gantry. So that's why I'm doing that, and I'm eager to do it, and I'm eager to show you guys, and hopefully help you guys out if you wanted to make some similar modifications. All right, so I'll see you guys when the rest of the video is ready to be made, and I might record some of me putting them in, because I don't think I did any of that with the others. So maybe I'll do a small amount of video while I'm putting them in and show you guys what I'm doing. But aside from that, I think I've kept you guys pretty well up to date. If you watched the last video on all the modifications, so in case you want to make them yourself, you'll have something to refer to that somebody else did it. And you know, I mean, I wouldn't say I made mistakes. I still have, as a backup, just in case I ever need them, I have the steppers and the stepper drivers for each axis, so I can always, and not the original steppers. I mean, I still have those too, but I have steppers, the more powerful ones that I got, and the more powerful drivers that I got. Because the drivers that they had, even the big one was analog, but the little ones were like pathetic. So I've got 4 of these digital drivers. So, and there's already one in there for the Z-axis. So I ended up with more than I needed. And then these little stepper motors are astonishingly powerful. They really are. These are, oh, I don't think the specs are on here, but these are like 4.5 amp, and these have more power and torque than the closed loop stepper on Z. These little ones have more power and torque. Matter of fact, I might just put one of these on Z. I put that one on there because I thought I might use the closed loop. I was considering using Mach 3, which I still haven't completely ruled out. I did get an extra Langmuir control board just in case anything happened to it, because I have gotten used to their software. But if I mess around with Mach 3 and like it, I'll probably start using it, because I already have 2 control boards for Mach 3 and one with a jog pendant. So I'll probably experiment with it at some point, and see how I like it. And if I do, then maybe I will use it. We'll see. But for the time being, this is the way I'm doing it. So stay tuned, and I'll fill you guys in as I go. All right, I appreciate all you guys, and see you soon.